Couchbase is a highly performant NoSQL database offering data format versatility and easy scalability, all without downtime. Couchbase Capella, or Couchbase in the cloud, is the easiest way to take advantage of a Couchbase database. Couchbase Capella is a DBaaS, or database as a service. It allows users to automate database setup, ongoing operations, and database maintenance, so you can fully focus on application development and how best to meet your business's goals. In this course, I'll walk you through Couchbase Capella and what it can do for you, whether you're a developer, an administrator, or just an enthusiast. Before diving into Capella, let's learn how Couchbase organizes and uses data. Couchbase is a NoSQL database that harnesses the power of a SQL database while allowing for NoSQL's flexible data solutions. It is highly available, provides low latency transactions, and is easily scalable, often without downtime. Capella is the user interface that allows you to see and work with Couchbase clusters all in one pane, like this view here. At Couchbase, we work with clusters, and a cluster is a group of interconnected servers or nodes that work together to support applications. In this example, Freedom Air has 3 clusters of data fueling different applications, including thick desktop applications, web applications, mobile applications, or any application built using an SDK. Let's drill into one cluster to see what it's made of. Cluster 1 is composed of 5 servers or nodes, which is not a requirement, but simply an example. The number of nodes is chosen by a user who sets up the clusters. In production, Couchbase requires a minimum of 3 nodes to ensure high availability. While Couchbase has 6 different services to choose from, this example configuration shows the 3 most commonly used services. 3 nodes are for the data service, and 2 nodes are split between the query and index services. More than one service can live on a single node in Couchbase, or a node can be devoted to a single service. That choice is yours. Another great feature of Couchbase is auto failover. This is where Couchbase automatically replicates data in a Couchbase cluster to ensure it's always available, even if one node or multiple nodes fail. This configuration shows the minimum recommendation of 3 data nodes, which you can see some are marked as active and some as replica. Replicas are kept in warm standby, so they're always ready to replace an active node when needed. So for example, if node 2 fails like we see here, Couchbase immediately activates its replicas to keep taking requests. As long as the appropriate number of replicas is present at all times, Couchbase will be highly available. And the best part is that users often will never know a failover took place. Now we'll look at the way data is partitioned for servers housing the data service in Couchbase. A bucket provides the first level of partitioning and can be compared to a database in a relational or SQL model. A scope lives within a Couchbase bucket, which lives on the data service nodes in the cluster. A scope is similar to schemas in a relational database. Then a collection lives within a Couchbase scope. Collections are similar to tables in a relational database. So this leads to an obvious question. Where do my documents go? In Couchbase, documents are housed in collections, and all key value operations are performed on collections. In Couchbase Capella, your 2 upload options for documents are JSON or CSV files. And finally, documents are similar to rows in relational databases. Companies that get the most out of Couchbase often fall into one of 2 categories. If your data is organized into microservices, it comes into the database under certain groupings. Scopes and collections allow you to maintain those groupings, so you're not reinventing your structure. When operations are coded, the database is directed to a collection of documents, speeding up operation times and increasing retrieval accuracy. If you have multi-tenancy, you want multiple non-related users to access data securely. Scopes and collections keep data in isolation, which ensures data integrity and greater security. So these are the building blocks of Couchbase. Understanding how Couchbase is organized will allow you to make Capella settings choices that strengthen and sustain all your applications. Getting into Couchbase Capella is quick and easy. You can do it in around 3 minutes. Let's start with a real-life example. Let's say my company, Freedom Air, is considering Couchbase Capella to simplify and accelerate database and cluster management. As a Freedom Air administrator, I want to explore the free trial, so I'll use this address to navigate to the Capella sign-up page. Here, I'll enter my name and all relevant information. And then I'll click Sign Up. Capella will then ask me to verify my email address by sending me an email. Remember to check your spam or promotional folders for this email. I will click Verify My Email, and just like that, welcome to Capella. On the left is an ever-present menu that's available on every Capella screen. Here you'll see Getting Started, Clusters, Projects, Users, and more. Towards the bottom, you can contact support, provide feedback, or view our documentation. For Freedom Air, I'm an administrator who'll need to set up the needed components for my developers to connect web applications to Couchbase clusters using the Capella UI. So here you can see my first choice is geography. In the free version of Capella, my options are Ohio in the US, Ireland in the European Union, or Singapore in Asia Pacific. If your organization needs other regions, you'll want to upgrade to the full access version of Capella, which you can do at any time. And just as a brief aside, it's important that when making this choice, you remember that maintaining low latency can be impacted by the geography you choose. Here is the full range of regions available in Capella, even though our examples show only the free trial options. If your servers are physically in the same region as the region you choose, your latency will most likely be low. However, if the region you choose is far away from your server's physical location, your database's latency will most likely increase, which decreases the efficiency of your application. Returning to the Capella UI, I will choose US as I'm located in the US, and then I'll scroll down and click Deploy Cluster. Capella will let me know that the cluster has been queued for creation, and just like that, Freedom Air is ready to take off with Couchbase Capella. Now that our cluster is up and running, our first step is going to be to add users, as you probably know right this minute who those people are. Within Capella, our first step is going to be to add users at the UI level. Within a few clicks, you can add all the users you need to the entire Capella UI. Let's look at our user options. An organization owner is the only user who can add or delete other users. This person has access to billing, can generate or modify API keys, and has full data access to all clusters, projects, and clouds created. The project creator is someone who creates the projects that organize your clusters of data. This person is also automatically assigned as a project owner for any projects they create. A cloud manager is a user that you would only add if you have previous experience with Couchbase. This person is someone who manages outside clouds hosted separately in Microsoft Azure, Amazon Web Services, or Google Web Services. And finally, an organization member has read-only access at the organization level for projects they're assigned. They can also be given more extensive permissions within the projects or clusters. And now we've returned to the Capella UI in order to add our users. My first step is to navigate to the users area. And because I've created this trial account, I will be listed here as the organization owner. In order to add a user, I'm going to click Add User. I will add the person's name and email address. Then, Based on the role that I'll need, I'll give John his organizational permissions. I'm going to make him a project creator so that he can create projects within Couchbase Capella. And then I click Add User, and Capella has told me that John Doe was added successfully. He will be listed as pending until he accepts his verification email. Also, it is very easy to delete a user, as all you would need to do within the Capella UI is click on the trash can and type the word remove in order to remove John as a user. Capella again will tell me that John was successfully removed, and I'll need to add all users who will interact with the Capella UI from this area. Now that your organization users have been added, you can add projects to Capella. Think of projects as a way to organize the clusters of data that feed your applications. Projects allow you to keep or adjust your current data structure and strengthen data access security. Here's an example of what the user structure looks like behind the Capella UI. Organization users are first added to Capella. Then projects are created, and users are given the needed permissions to work within each project. Each project can house one or more clusters of data, and a user with access to that project has access to all clusters within the project. So, if I have 5 developers with access to this project on the screen, each developer will have access to all 3 clusters within this project. Making sure you understand this is key to maintaining data security. And it is a best practice to plan out which clusters logically need to be linked within a project. To do this, you may want to gather your team and whiteboard the answers to these 2 questions. Number 1, how are my applications organized today? And number 2, how do I want them to be organized in Capella? When Freedom Air planned out their project structure, they decided to separate projects out by housing applications for airports in Project 1, for flight paths in Project 2, for airlines in Project 3, and for regions in Project 4. This way, they gave access to clusters following current data structures. Let me show you how easy it is to begin creating a project structure in Capella. Just so that you're aware, I've cleared all of the trial information so that we can start with a blank slate for this demonstration. From the menu on the left, I would first click Projects. Then I will click Create a Project, and I'll give my project a name, Project 1. I click Create a Project, and automatically Capella has told me that Project 1 has been successfully created. I can then go about adding Project 2, Project 3, and Project 4. To add users to a given project, I will first click on the project name, and here you can see 2 options: the clusters identified as part of this project and the users. We'll click on Users, and I'll need to click Add Users to Project. From here, I'm going to use the drop-down menu, and I'm going to choose the user I'd like to add. Remember, users must first be added at an organization level. If the user is in Capella, they can be selected from the drop-down menu. If the user is not in Capella, they will not be present in the drop-down menu. From here, I'm going to give this user project owner permissions, and I'm going to click Add User. Capella has told me that I've successfully added 1 user, and now Michelle Burns has been given options to work within any clusters within this project. Within the user options were 5 different roles, and I'd like to show you where you'd find out what the capabilities of each of those permissions are. You can do that by clicking on Documentation on the left, then click on Organizations and Access, Organizations, and Manage Users. This is the most up-to-date information about Couchbase Capella supplied by Couchbase. And here you can learn more about the capabilities of each of the users within Capella. I'd also like to make a quick note here that my examples cover multiple projects and clusters, but please be aware that the free trial version of Capella can create many projects, but you can only spin up one data cluster. If you need more than one data cluster, please upgrade to the full access version. While segmenting databases into projects takes time, once identified, they enhance database visibility and data access security, well worth any time spent. With Couchbase Capella's 30-day free trial, you can easily take a Couchbase database for a spin. This section will show you what you get and how to view the data included with the trial cluster. Let's start with an example. As a Freedom Air database manager and developer, I came to Capella to see how Couchbase can handle my needs. But in order to do any of these things, I need to know how my cluster is configured and where to find my data. In order to do that, we will navigate over to the Capella UI. Now that our cluster is up and healthy, indicated by this green dot here, let's look at some of the configurations that are set by default. First, I will click the name of the cluster to view the details, and then I will click Configuration across the top. As part of the trial cluster, we're on a basic plan, which enables us to have a one-node cluster with 4 of the Couchbase services, including data, index, query, and search. My compute viability is 2 virtual CPUs at 8 GB of RAM. My disk type is GP3, Amazon's EBS general purpose SSD volume type. My storage capacity is 50 gigabytes, and I have 3,000 input-output operations per second, or IOPS. If you want any more than what's here, you can always hit Upgrade to get the full access version of Capella. Now we're going to navigate to Buckets to view the data that Couchbase has put into this bucket by default. I can see here that my bucket, which is called Travel Sample, has over 63,000 documents in it. It uses 76 MB of in-memory data, and the disk used is about 55 MB. If I click on the title of the dataset, I can make adjustments to the bucket behavior under Advanced Settings. For example, I can enable flush or specify a time to live for documents. Both of these settings are disabled by default. Before we get any further into the documents and how they're structured, let's walk through a reminder of how Couchbase breaks documents out. Use the bucket to get the appropriate scope. Use the scope to get individual collections and perform queries across the contained collections. Use the collections to perform key value operations on JSON or CSV documents. Remember, too, that each of these segments align with a relational database in this way. Buckets are databases. Scopes are schemas. Collections are tables. And documents are rows. Returning to the Capella UI, where can I find these buckets, scopes, collections, and documents? Within the Buckets tab, I will click on the 3 dots icon at the end of the dataset row here. Now I can see my options for scopes, collections, and documents. I can also delete the entire bucket if I so choose. In order to see the information specifically in each dataset, you can click Documents. And you can see that documents are separated out by the bucket, the scope, and the collection. I can also change the limit of documents I see on a single screen from 5 to 200. Finally, if you wanted to delete all the preset data and import your own data, you would simply need to delete the buckets and then click Tools and Import, and then import your own JSON or CSV files into your own named bucket. Congratulations! You have your very first cluster in Couchbase Capella, and you are now ready to run key value operations, queries, and indexes against the data inside it. You know, we've waited long enough. Let's get Freedom Air's trial cluster connected to Couchbase using Capella. To make life easier, I've pasted an example of the Node.js connection code into our IDE Visual Studio Code. Let's see what we have here. Across the top, the requirement statement allows access to the Couchbase modules. Then we have 4 variables to define: endpoint, username, password, and bucket name. Below that is the connection code. And at the bottom, I've customized this by adding a ping to verify the connection and a console.log to print the ping result. Whether you use these additional lines is totally up to you. Now, where do I get these variable definitions? That'll be back in the Capella UI. So let's go there now. My first step when I'm looking at my clusters is to click on the cluster name to view details. Then I will click the Connect menu. Here is a variety of information I'll use to connect to the Couchbase cluster. But first, I'd like to show you a developer's paradise of information. If I click on SDK examples, you can choose any of the language examples and use this code as a starting point for your application. To close this, I'll click the X. And we're going to copy the endpoint here as that's the first variable that's asked for. Then I'm going to go up to buckets. And I'm going to take note of our bucket name, as that will be required for the connection code as well. I'll navigate back into the IDE, and I'll paste my endpoint address. Then I'll key in travel sample as my bucket name. The other 2 variables I need to define are username and password. It's very important to call out that you will need to add a user with database credentials, which is different from the username and password that you use to sign into the Capella UI. I'll return to Capella. I've returned to Capella in order to add database credentials by clicking Connect and scrolling down to Database Access. By clicking Connect, I can see where we have database access, and I'll click Manage Credentials. From here, I'll click Create Database Credential, and this will automatically list information from users that are added into Capella. In order to make this easier to remember, I'm going to change the username to FA Client App, and then I'll key in an appropriate password. As you can see, Capella will keep track of whether or not you've hit your password requirements. And I'm going to want to take note of this password. Finally, I can make bucket selections, scope collections, and access selections using the drop-down menus. So I'm going to choose the bucket travel sample. I'll focus on all scopes in the bucket. And then I can choose my access of read, write, or read and write. Once I've made my choices, I could add another user by clicking this button here, but I'm good with this one user for now, so I'll hit Create. Capella tells me that database credentials have been added, and now I can return to my IDE to key in those variables. My username is FA Client App, and my password is here. The last thing I need to do is make sure that my IP address is whitelisted so that Couchbase can connect to my client application and where it will run from. This connection could be your local PC or possibly an EC2 instance where the app runs. In order to whitelist the connection, I'm going to click the back button, and now I'm again on the Connect menu. I'm going to click Manage Allowed IP. And as you can see, there are no IPs allowed here. So I'll add an allowed IP. I'm going to make a choice whether or not I'd like this to be a temporary add or a permanent add. And I'm going to leave it at permanent. Also, because I'm working from my local machine, I can use the button here, add my IP, or I could paste in a different IP address if I'd like to. From here, I'm going to click Add IP, and Capella will tell me that this IP address has been successfully added. Now we're ready to test our connection. We've entered all the variables here, and we'll save the code. And then I'll key in node app.js and hit enter to run the code. As you can see, the ping result has told us that the connection was successful. And there you go. Freedom Air's trial cluster is now connected to Couchbase using Couchbase Capella. It's time to apply the skills we've discussed in this chapter. When you've finished with this challenge, you'll have your own Couchbase Capella single node cluster. You'll be able to connect to that cluster and start developing against it. Working this challenge will mean you will complete these steps. First, go to cloud.couchbase.com/sign-up and sign up for a free trial cluster. This may take a few minutes. Second, view the data that is automatically loaded into that cluster, or, if you prefer, import your own data to work with. Third, add a user under the Database Credentials area of the Cluster Connect menu. Fourth, whitelist your IP address to allow your application to connect to the Couchbase cluster. Fifth, choose whichever IDE, Integrated Development Environment, and Software Development Kit, SDK, you prefer to code with. Look at the exercise files for website addresses for Visual Studio Code IDE, as well as the addresses of where to find any of the 9 Couchbase-supported SDKs. Sixth and finally, enter the appropriate connect code and run your code to show you have connected to your trial Capella cluster. Depending on the setup and download speeds, completing the steps of this challenge should take you no more than 10 minutes. Good luck! Now let's walk through the steps from the challenge activity. My first step was to navigate to cloud.couchbase.com/sign-up and fill out the information to get a free 30-day trial of Capella. I selected the U.S. geography of Ohio, as that's my only option, and I hit deploy. It took about 7 minutes for my trial cluster to spin up. Once my cluster was healthy, I could see it here on the dashboard. And in order to see the data within this cluster, I clicked on the trial cluster name and navigated up to buckets. From here, I took note of the fact that my bucket name was travel sample, as I'll need that for my connection code. If you added your own data, you would go up to Tools, Import, and then you would import your JSON documents or CSV file as needed. In order to set up the connection, I clicked on Connect, and then I scrolled down to add database access by giving someone database credentials. The username I provided was FA Client App, and then I took note of the password that was added as well by creating database credential. This gives me access to the Couchbase cluster. I also chose my bucket and scope options, as well as read-write access for this particular user. Then I clicked on Back, and my next step was to manage allowed IP addresses. Because I'm working on my local machine, I added my personal IP address, and then I went back to copy the URL address of my Couchbase cluster. Finally, I got all of the code information on how to code this in Visual Studio Code. My first step was to add the dependencies, package.json, as well as the Node.js Couchbase dependencies under node_modules. I copied this code from the Capella UI and then added my variable definitions here. I added a ping result as well as a print instruction, console.log, so that I could see that ping result. And then I saved and then ran the code. And as you can see here, I've successfully connected my Capella cluster to my client application. As a developer, your next step is probably to build out application functionality by coding key-value operations. Using a connected Couchbase database, as you can see the code for here, you'll first obtain the bucket and scope, and then you need to remember that key-value operations are only completed on a collection. Now we're missing that collection code, and I want to find out some more information so that I know the correct document IDs to test on. To find that, I'll return to Couchbase Capella. From the dashboard of Capella, I'm going to click on the name of our cluster, trial cluster, to view the details, and then I'm going to navigate to Tools. I'll select Documents, and here I have some options. The first drop-down menu is for any of the buckets within this particular section. I'm going to select from the Scopes area and choose Inventory, as that's the scope I'd like to look into, and then I will choose the collection of airline. I'm going to take note of this document with the ID labeled airline_10123. That's what I'll use to test my get operation. And now I'll return back to my Visual Studio Code IDE. And for simplicity's sake, I'll just paste the code I have in. Let's see what I've added. From here, I've added the collection named airline. I've asked for the get result with the await prefix and the get method. My airline_10123 ID is here. Finally, I'll ensure the result is returned as an object using console.log. Now I need to save the code, and I'll run this. And as you can see, this has returned the information for this particular document. And now you've completed a get using the Node.js SDK and appropriately finding the document key within a Couchbase database. When getting started with Couchbase, you might find that it helps to spend a little time better understanding how to perform required application tasks. Let's talk about the common operations insert and delete and Couchbase's operation of upsert. As you probably already know, an insert assumes a document does not exist, and if the document for a given key does not exist, the code provided inserts the document. This is the opposite of a delete operation, assuming that a document does exist, and the code provided removes that document from the database. An upsert is specific to Couchbase. It does not assume the pre-existence of a document, and so it will take one of two actions. If a document does exist, that document is updated for a given key, and if the document does not exist, it is inserted just like an insert operation. Now we'll return to the IDE to show you what an upsert looks like. This code should be familiar to you by now, with the cluster information, the bucket, and the scope already listed. To make life easy, I'm going to paste the rest of the code in for an upsert. And as you can see, we've added the collection listed as airline. The result is set to an upsert, and this is the document that we are upserting. If you need a simple insert, you would simply change this method from upsert to insert. Now I'm going to save the code, and I will key in my run command and hit enter to execute the code. As you can see, I have a CAS value and a token for this newly upserted document because previously airline 2212 did not exist, and now it does within the database. I will now replace the information for the upsert with the code for delete. And I have that here. I'll copy and then paste this back into the IDE. And with this one, we're simply adding the result and removing the document labeled airline_10, which is the ID. I'm going to save this information, and then again, I'll run the code. And as you can see, this operation has been completed, and the document airline_10 has been removed from our database. And just like that, we've completed 3 different operations: insert, upsert, and delete for our database set of documents. Okay, so everything is going well and your code has been running the exact results you want. But what happens when an error or an exception does come up? We all know that errors happen, and the best developers will always test and plan for them. To see how to do that, we'll slip back into the Visual Studio Code IDE. Here, I've written and saved code to remove a document called airline_10. When I go down to the terminal and run the code, I can see that I have a document not found error, also known as a document not found exception in languages other than Node.js. If uncaught, errors could be propagated to the web layer, which can cause headaches for you as the developer. To improve this, and to save time, I'll paste a try-catch block into the code. And as you can see here, I've added an error message and a key identifier for the erroring operation. I'll hit File and save the code, and now I'll go into the terminal and run the application. Success! The error is now handled in that it's caught and displays a user-friendly message with a key reference. And that's how we can code our application to provide appropriate and helpful outputs when errors take place. I hope you feel ready and excited to try out the skills we've just discussed by completing this challenge. When you finish this challenge, you'll have working Node.js code for 1, maybe 2 key value operations. If you want to use a different coding language, please reference Couchbase's website on SDKs for more examples. Okay, so this challenge asks you to complete each of these steps. First, go to Capella to view your cluster's dataset, making note of the names of the buckets, scopes, collections, and document IDs for the data you'll use. Second, in the IDE of your choice, complete 1 of 2 key value operations, either get or delete. If you really want a challenge, you can do both. Please note the solution to double-check your work will be in Node.js. Third, change the document key so the operation fails. Fourth, add a try-catch block to the operation with the text for catching the error. Fifth and finally, run the code and receive the error information as expected. Depending on your familiarity with the coding options, this should take no more than about 7 minutes. Good luck! So how did this challenge go? You have some options to choose from, so I will show the code for 2 different key value operations. Please remember that I'm using the Node.js code. If you're using a different language, please refer to the Couchbase documentation for those code examples. I'll start by pasting in the get code. When looking at this code, please note that any of the key value operations will start by obtaining the bucket, scope, and collection, as you can see here. The catch block is written to catch any errors thrown during the get operation in the try block. Now I'll save this, and I'll run the application. And as you can see, I've received my expected results. And for those of you who chose the delete operation, or for those super students who did both operations, I'll paste in the delete code. Again, you'll notice that we've still named our bucket, scope, and collection. We've entered the appropriate try-catch block, and we've changed the user-friendly messages as appropriate to a delete operation. Now I'll save this code, and I'll run it, and voila, I've received the expected result. I hope this challenge felt simple and understandable. And if you'd like to try other operations or other languages, please refer to Couchbase documentation for more code examples by SDK. If you're familiar with SQL or SQL, you're familiar with Couchbase's SQL++, which you may have seen referred to as N1QL or NQL. So what is SQL++? First and foremost, it's a query language that used to be called N1QL at Couchbase, or non-first normal form query language, and it was started in 2015. And now, NQL is being rebranded to SQL++. SQL++ manipulates JSON documents the way SQL manipulates data in relational databases. SQL++ extends SQL to handle nested data that is schemaless and non-uniform, and it also handles data containing arrays and objects. Looking here, you can see the syntax and standards are nearly identical. For example, your select, where, and group by, as well as the other statements here, are identical. There's only a small change in your from statement. So you can clearly see if you know SQL, then you know SQL++. We'll now return to the Capella UI to work with these statements in our query workbench, and you'll see just how easy it is to query in Capella. Navigate to the workbench by clicking on your cluster, selecting Tools, and then clicking on Query Workbench. On this screen, you can see Capella's query editor. There are two drop-downs for you to select the appropriate bucket and scope that you wish to query from. The Execute button is here, and Capella will give you instant feedback after your query's been executed. On the right-hand side of the workbench are data insights. They give you additional data information based on your query results. To show you this in action, I'll paste in a basic query and click Execute. You can see the evidence that the query ran by looking at the green check mark here, and Capella shows you the time elapsed, 13 milliseconds, the execution time, the docs that were returned, 10 documents were returned, and the size of the query. You can also use these buttons here to toggle between the results in different formats. JSON will always be the default format. However, you could view this in table, plan text, or plan if you choose to. There are a few special considerations you want to keep in mind when you're working with SQL++, and they are SQL's distinct function, the use of special characters, case sensitivity in SQL++, and Couchbase's upsert function. Please note that when using SQL++ or NQL, you can use the distinct function the same way you could use it when querying with SQL. Another special consideration is the use of backticks when your collection or field names have any special characters like the ones on the screen. You must also use backticks when you use reserved words. The code examples here illustrate the correct use of backticks when querying. Please take note that unlike SQL, in SQL++, attribute descriptions and bucket names are case sensitive. However, the querying keywords are not case sensitive. And finally, please know that the upsert command, which is specific to Couchbase and SQL++, can replace the content of an existing document, or it can insert a document that does not yet exist. This is something that's not available in SQL. Just so you have it on hand, here's a comprehensive list of common operations used in SQL++ querying and their definitions. For example, the from statement allows you to specify a collection to query from, or the join statement allows you to join selected fields for documents in a collection. Now that you have the basic concepts for querying in Couchbase, I hope you can see how if you know SQL, you are ready to take on SQL++. In a modern world, everyone needs more speed. And no one wants to be the developer of a good but slow application. To that end, indexing becomes important. Indexing is one of the keys to ensuring your data can be reached quickly and results returned accurately. And just so we all know what we're discussing, we'll define an index as a data structure queries use to find records in a database faster. Who creates those indexes? You, the developer. And you create indexes by understanding the querying needs of a data set. Adding indexes creates more efficient paths to frequently search data. At Couchbase, indexes are required, but if they help your users get the data they need faster and more accurately, why wouldn't you use them? Let's look at this in action in the Capella UI. I'll start from my clusters area and click into my cluster. Then I'll go up to Tools and click Query Workbench. From here, I'll paste in a basic query with only a primary index. This query calls for the name and created attributes of all documents within the airline collection in the inventory scope. And I'll click Execute to run the query. And now I can see that in 18 milliseconds, 10 documents were returned by the query at a size of 401 bytes. I know I can make that faster by adding an index that isolates the collection data for name and created fields. So I'm going to highlight what's here in the query editor and delete it. Then I'll paste in my index. I'll click Execute, and in a few seconds, my index has been created by Capella. Now I'll use the History button to pull up my previous query, and I'll click Execute again. Wow. Now, instead of 18 milliseconds for the execution of this query, I've gotten the same 10 documents and the same 401 bytes in 3 milliseconds. To go from 18 to 3 may sound insignificant, but when thousands of transactions are running every second, the time savings that results in a more efficient querying is highly significant. Within Capella, you can manage the indexes you use by clicking Tools and Indexes. From here, you could use the trash can icon to delete the index, or you could drill into the index and open it in the query workbench to make adjustments and execute it again. Partial indexes provide another way to index data to see better querying performance. Looking at the example here, this partial index covers a subset of documents in a collection. It can consume substantially fewer system resources. The where clause, shown here, filters the documents that will be covered by the index. But when making your index choices, as with all things, you must weigh your costs to the benefit and see which one is worth more to you. For example, indexes consume more resources in your database. However, they can directly increase result return time and accuracy. Weighing the benefits versus the costs carefully in order to get the best performance is what all good developers do. And that's how indexing can ensure your queries get your users the information they need quickly and accurately. Setting joins is one clear way to enhance querying. Joins are connections between information in different document sets. They can increase efficiency and make querying more effective. The best strategy when writing effective joins is to let the end result guide the journey. Before completing a join, stop and ask, what information do I want users to see or access? In this example, I'd like users to see more information than what's in one document alone. Let's look at the documents and see what I mean. These two documents have many data points, but on the left, an airline code of airline_137 is probably not familiar to my users. So I'll join the right side document with the key airline_137 to give my users the airline name and other details they might need. Because this is a key value operation and Couchbase is a key value store, no index is needed for this join. But how does this look in the Capella UI? Let's check it out. From my query workbench, I need to remember to first select the bucket and the scope that I'll need for this query. Then to save time, I'm going to paste in my query. And as you can see, the join is included in the query language. I'm joining the collection for route to the collection of airline. And now I'll click execute. And the query will call up all the information in both documents. When a user calls for this information, they will not only see the airline ID, but its name and other relevant information as well. Couchbase can perform many different types of joins, but now you can see the basic mechanics behind writing joins in queries with Capella. Named and positional parameters can help you ensure that common queries can be executed well, even if the variable values change often. When a query comes in, like this one on the screen, Couchbase parses all the statements and prepares an execution plan, as you can see here. But if you decide to use parameters, the query plan is prepared one time, and then the query can be easily executed any number of times thereafter with different values. Let's see where to find this in the Capella UI. I'll start by clicking my cluster name, then navigating to Tools, and clicking on Query Workbench. Then I need to remember to select the appropriate bucket and scope that I'll be working from. To save time, I'm going to paste in my query. And as you can see, I already have the parameter called out here. Then I'll click into Settings, and I'm going to click the plus sign next to Name Parameters. I'll add the word name. And in order to test the query, I'm going to add in a value. As you can see, my positional parameters are also here, and I could add that by clicking the plus sign again and adding a positional parameter. But for right now, I'm going to only work with named parameters. I'll click Submit to save, and now I can click Execute so that my query will run more efficiently, even if the values of the variables searched change. By using the single pane design of the Capella UI, you can see many metrics for your database. Let's look at what's here. I'm going to click into my database, and when I first come into my cluster, I can use the data service template for my metrics by clicking here. And Capella will pre-fill common metrics, including CPU utilization by node, cluster get operations per second, connections, or memory used by bucket, and some others that are here. You also have the ability to set your monitoring frequency. You can have as little as 30 minutes worth of a view or 30 days worth of a view. If you want to customize your metrics view, you can click on the X on any of these metrics to remove them. Or if you'd like to add a metric, look to the right in gray where you see Add Metrics, and then you'll choose your service. Remember that your service has to be present in your cluster in order for you to be able to see that monitoring. I'm going to choose Data, and then I can scroll through the different options that are here to add a particular metric in real time. Hopefully, the information you find here will help you make needed adjustments to your database as quickly as possible. Capella offers a variety of different metrics to fit your needs, and new metrics are always being added, so check back often. As the needs of your database change, Capella can scale in a matter of minutes rather than hours or days. Please note that all the examples here are in the full access version of Capella and will require purchase beyond the free trial. Also note that as you make scaling changes, your credit costs will change, and you probably want to check in with your organization owner before you save those changes. After your cluster has been up and running for a while, you can click into the cluster details and view the metrics for CPU utilization by node, which is a common measurement to judge database performance. Let's imagine the CPU usage is too high. What can I do? I can scale in 3 different ways. I'll click on Configuration to see my options. Here I can see that I currently have 3 nodes, which is the minimum requirement for a production-ready cluster. I can increase that number easily by using this drop-down here, and I'll up that to 4 nodes. From here, I will click Update Configuration, and Capella will ask me to confirm my options. I'm fine with what's here, so I'm going to click Confirm. And now Capella has told me that the configuration will be successfully updated and to allow around 15 minutes for the changes to take effect. However, it could take less time than that. And just like that, my number of nodes has been expanded and my CPU usage will likely go down. Another option for scaling is to utilize the compute feature here. As you can see, we currently have 4 virtual CPUs with 16 gigs of RAM. If I use this drop-down menu, I can see a variety of other options. And let's just say we'll double everything by changing this to 8 virtual CPUs and 32 gigs of RAM. Again, if I make this change, my credit costs will be changed as well. You may want to check in with your organization before you do that. Capella will ask me to update the configuration and then to confirm my choice. Once I do that, Capella will tell me that this could take up to 15 minutes, but again, it may take less time than that. Okay, so in a matter of about 20 minutes, our virtual CPUs have doubled and our RAM capacity has also been doubled. Finally, I can also exercise an upscale in storage capacity by clicking up here or down as needed. Again, our standard is 50 gigabytes, but you can raise that standard as needed. Clicking here, you want to pay attention to the fact that the storage is per node, so keep that in mind. You can update the configuration by clicking Update Configuration again and confirming, and Capella will tell you it takes about 15 minutes again. That time varies. This will also impact your credit amount, so again, you may want to reach out to a member of your organization before you make these changes. With these 3 options in the full access version of Capella, I didn't manually add or redistribute in order to scale my cluster. I made the selections and allowed Capella to automatically make the needed adjustments in minutes rather than in hours. All the while, my users have had access to my database. Database security and availability are at the top of any manager's priority list. That's why database replication, another feature of Capella, is so helpful. Please note that when using this feature, you'll be required to purchase the full access version of Capella beyond the free trial. Also, adding replication may change your credit costs, so you probably want to check in with your organization owner before you save these changes. What is replication? It's having 2 copies of a database in 2 different locations to ensure that if one goes down, the other can take its place quickly and without user interruption. Let's jump into Capella to see where we can find this feature. First, I'm going to look at my clusters that I see here on my single pane dashboard view. It's important to note that you must have the original and the replication clusters created prior to getting started with replication. Here you can see I have Freedom Air 1A, and that's listed in the United States in the state of Oregon. And then I have my replication cluster as Freedom Air 1B. That will be in the European Union, in the country of Ireland. So the geographic location of the server will hopefully ensure one cluster outage is not impacted by the other. I'm going to click into my Freedom Air 1A cluster, and then I'll select Replications. From here, I'll start my replication by clicking Setup Replication. I have some options to choose from. The first is a one-way replication or two-way. I'm going to leave it as one-way for now. Then I'm going to choose the clusters that will be replicated. Freedom Air 1A is selected because that's the cluster I clicked into. I will use the drop-down menu to choose the other cluster. And it's important that if you didn't create the cluster in the previous step, you won't see this other cluster in the drop-down. From here, I now can select the buckets to work from as well. I'm going to choose my source bucket. And then it's important that your target bucket has the same labeling as your source bucket in order for the replication to complete. I'm going to click Next. And from here, the collections have the same requirement. Scopes and collections that do not exist on the target cluster with the same names will not be replicated. I'll click Next, and I could set filters if I'd like to, but for now I'm going to stick with the defaults. And I'll click Next again to go to the settings, and I can make the choices here, but for right now I'm going to stick with my defaults. From here, I will click Setup Replication, and Capella will tell me that this replication is currently taking place. It's important to note that Capella will ensure operations conducted during the time of replication are completed. As soon as the replica database is available, the operations that took place during the setup time will complete. And just like that, Capella has let me know that the replication has been added. My database is replicated and available in case a node or cluster fails. Capella has automatically made all the adjustments to ensure my two databases are synchronized.